Today's integrals are going to involve ln of x. It might be that ln of x is in the answer, or it might be that ln of x is in the problem. Again, we're trying to find the antiderivatives, and our first rule is to talk about the integral of 1 over x. I don't know if you remember, but if you take the derivative of natural log of x, you do get 1 over x. If you tried to do our rule and add 1 and divide by it, you would get x to the 0 over 0, which we know is not okay. And so this is just one of those rules that we've talked about. When we took the derivative of natural log of x, you do get 1 over x. So we don't do this process of the power rule, we just know that this is our rule. So let's say that we have a problem like this, the integral of 2 over x. Well, we know that 1 over x, the antiderivative, is natural log of x, and we just have a constant with it. So this would be 2 natural log of x plus c. Unfortunately, they're all that easy. We may have to use u substitution, which we've talked about. And in problems like this, u substitution is involved by allowing u to be the bottom. You know, we've let it be things that are in parentheses, and if you wanted to think about bringing this up and making it to the -1 power, that u would be the 2x minus 1. So we're going to let u be 2x minus 1, which means du is 2. This is nice because our 2 is already there. We know we have our dx there, so this means that we've got the integral of 1 over u du. Well, we know the antiderivative of 1 over u is natural log of x. So this is natural log of u. Go back and substitute what u was, and u was 2x minus 1. So our answer was natural log of 2x minus 1 plus c. And this happens whenever you end up with u being on the bottom by itself with nothing else there. Number 3. You could do u substitution with this one if you wanted to. I personally would probably just rewrite it as 5/7 times 1 over x, because now we just have a constant times 1 over x. So I know that the antiderivative here would be 5/7 and then natural log of x. You can do u substitution and allow u to be 7x, and it'll work it out. You'll end up with that same answer. You might have a 7x inside of here, but essentially that is the same answer, even if that 7 is right there. Okay, on number 4, this one is another one where we're just going to do a u substitution, because I can tell that that's the only thing really to do. We're going to let u be negative 2x minus 5. We're going to let du be negative 2. We don't have our negative 2 in here, so we're going to put it in there. We want to put that negative 2 in there, which means I want to take the negative 1/2 out. And so I don't get confused, I'm going to go ahead and take that 3 out. So this will give me the negative 3 over 2 integral of 1 over u du. Now we know the antiderivative of that is just natural log of u. So this is negative 3/2 natural log of u. And there is an absolute value on this technically, so if you ever see that absolute value, it's okay. It doesn't really change anything. It's just because you can't take natural log of negatives. And then you substitute what u is back in there. It does look like this is negative, but it really isn't, especially when you plug in negative numbers for x. You'll get bigger positives if you plug in the right numbers. That's the reason for that absolute value. So number 5, again, we're going to let u be the bottom. That means that du is 2x. This is nice. We already have our x. That means we're going to put a 2 in and take a 1/2 out. So when we rewrite this, this means we've got a 1/2 and then 1 over u du. 1 over u is natural log, so we know that this is 1/2 natural log of u, which means you get 1/2 natural log of x squared plus 1 plus c. Alright, on this next one, I just wanted to show you that just because there's something on the bottom doesn't mean that you're going to end up with a natural log. This is a problem we've done before, but I just wanted to remind you of it. If you let u be x minus 1, du comes out to be 1. There's nothing to change here. So this means we have 1 over square root of u. This is not natural log. The natural log of u is only when you're taking the antiderivative and you get 1 over u. Okay, that's not what we have here. This is the same as u to the negative 1/2. And so this is a power rule problem. So you only get natural log when you take the antiderivative if you have only u there and no powers or anything like that. So I just use my power rule. I add 1, divide by 1/2, or multiply by the reciprocal. Go back and substitute our u in. I just wanted you to realize you don't always get natural log when you let u be something on the bottom. We couldn't have let u be the square root of x minus 1 because there's not another square root there for the du part. Alright, let's look at a few more problems. This is another one just to show you answer is not always natural log. You do let u be x squared minus 4. Du comes out to be 2x. Put in that 2. Take out that 1/2. And that gives us 1/2 integral 1 over u to the third. Again, just because you have a u doesn't mean it's a natural log. On the bottom, we're just going to rewrite that with a power rule because it's not just a u. And then the power rule says add 1, divide by it, so really times by the reciprocal, and that's negative 1/4. Substitute back what our u was, and we get that. Alright, the other kind of problem I wanted to show you real quickly is that if there is a natural log in the problem, that you can let u be natural log of x. And the reason that that works out nicely is because du comes out to be the derivative of natural log of x, which is 1 over x. And if you look here, that's nice because the problem is already solved correctly for us. So that's just u du. And now we just do that like we have been with the power rule. So that would be u squared over 2. Plug in the u. And then that's what we get for our answer. So if there's a natural log in the problem, that's going to be the u. So sometimes it's on the bottom. Sometimes it is what's in parentheses. Sometimes it's the natural log. So looking at this problem, the only thing that we could let u be would be that 1 plus cosine of x. Du, we're going to take the derivative here, so you get negative sine x. That just means we're missing a negative here, which means we take a negative out. So we would have negative integral 1 over u. Natural log, that's natural log because there's nothing else with the u. So I wanted you to see that you can do natural logs with trig functions. I guess this should have been negative natural log of u, and I went ahead and substituted what that was, and so that's that answer there. Last problem was just to show you that you can combine all the rules. This is a natural log problem because we just have an x on the bottom, so this would be 10 natural log of x. This is a problem where we want to use the power rule, so we add 1, which is negative 1, and divide by it. So that negative and that negative is going to make it be positive, and then that's our answer. So we may use a natural log rule and a power rule in the same problem.